my presentation, I will speak about a quick resume about the project and the recommendation document. Then I'll speak about uncertainty, which is the core of this project, and then I will try to speak about the lesson learned found in the first results of REMY. So, okay, this is the partner. So we as Terraria consultancy company in Milan, we are the coordinator. We have the municipality agency, environmental municipality agency in Milan, which is AMAT. We have RSC, an Italian partner. Then we have YEP, which is a Poland partner, and then we have XIC from Spain. So, which is the object, the aim of this project? REMY stands for Reducing Emission Modelling Uncertainty. So it started 2 years ago, and so we will finish in 3 years, the next year in spring. So uncertainty is the core, and the final aim is to produce harmonized recommendation. I think that I should underline that this recommendation we want to be based on our emission and modeling results. Firstly, on that. This is, I think, our important aim to be reached. At the end, the draft, we have a draft version of this recommendation document, and the final one will be available in spring, in April of next year. So these are the 3 areas where we are working on. So we have the really famous Po Valley, Alain already talked about it. So then we have the southern Poland area, and then we have Catalonia with both a regional, 3 regional domains, and also 3 urban domains. So one is Milan, of course, one is Barcelona, and the other is Krakow. For each of these domains, we do simulation both with CPM, both with receptor modeling and urban modeling, and in Milan also with RIAD Plus, so with an integrated assessment tool. So first of all, the object of our project is uncertainty. So how uncertainty is defined? It is the accuracy of the emission estimate that member state should report together with the emission. So this point is important. What kind of uncertainty we have worked on in REMY? We worked on all the dimensions of the emission process. The emission process depends on space, time, pollutant, and activity. So we need to focus on emission factors, uncertainty, to activity indicator uncertainty, and then to all the process of spatialization, temporal modulation, and chemical speciation. How can you estimate emission uncertainty? The direct method is a method really rarely used. So it means to attribute an uncertainty to the emission factor, attribute an uncertainty to the activity indicator, and then multiply with the propagation error these 2 kinds of uncertainty. Other indirect ways and simplest ways to estimate it is, for instance, to use this classification A, B, C, D, E provided by EA. A is the less uncertainty, and E is the most uncertainty. Or another way is benchmarking approach that UP7 yesterday already explained us. So yeah, this is the classification depending on pollutant and macro sector. So SO2 is the less uncertainty, while ammonia is the high degree uncertainty. And also sector, you start from industry, less uncertainty, and agriculture or nature, more uncertainty. This, for instance, we have to know what it's mean it's meant with industry, because, for instance, of course, big industry is well known, but small, medium enterprise emission are not known. We will see later. So be careful to use this simplified approach. So on which uncertainty we have to focus? Of course, we cannot focus on all the emission inventory because it's too hard. So we suggest to use this very simple approach to focus on the emission sector with the most significant emission multiplied by the uncertainty. So you find a weighted sector emission uncertainty multiplying these two parameter, and you should do it for each pollutant. So in order to prioritize the sector and the pollutant where you have to focus on the uncertainty. So now what we have done in REMY. So you will see by parentheses the action that focus on this point. So A2 means action of, in this case, it's led by JEP, the Polish partner. They are developing a tool, an emission tool. You see the link of the prototype. What does this tool? It's do something similar to the tool developed in Jersey, but it is working on a gridded, not on a cells and not on nuts, as yesterday was shown. So it produces the relocation at different resolution of inventory to help countries that do not have high resolution inventory, and to help also the benchmarking with bottom up. So to produce a top down at the same level of your bottom up inventory, and then to check the inconsistency and so define a first level of accuracy of course. This method do not say which of the two inventories is correct, because both could be right or both could be wrong, but helps to find inconsistencies. So you see an example of this tool. You see the pollutants, so the main precursors, and you see the resolution up to half a kilometer resolution, and the data can be downloaded in an open format. So which are the first lesson learned? This is a useful tool, but of course, when you relocate top-down inventory, you cannot reproduce hotspots because it's a relocation process. It's not, and for instance, you cannot put the same emission on the road network in the city. And again, top-down will be different by definition from the top-down, but it could help to have inconsistency check. So then measures on emission factors and activity indicators. This is action A1. So few spotlight. So first, resuspension. So resuspension from the analysis on the PM source apportionment studies demonstrates that this contribution is fundamental in the urban areas. So needed to be included in the emission inventory. 4 standardized approach have been used to estimate roughly the uncertainty, which is estimated by SIC and AMAP to be around 60%. And you see some first results for Milan, which is 3 to 60 milligrams per vehicle kilometer traveled, or in Barcelona, which is 3 to 10 the emission factor, and the difference is due to the different pavement and traffic fleet. Then open waste combustion, this is a not significant contribution of PN, but it is important from a health point of view, because this could cause the emissions of cancerogenic pollutant. So it would have a significant health impact at the local scale. Of course, the activity indicator is highly uncertain. Domestic heating emission factor from traditional boilers are very stable, so no problem using standard emission factor. When you go on newly boilers, for instance pellet boilers or condensing boilers, the measure done in this project shows some difference. So sometimes it would be useful to have some local emission factor. The same is for wood oven pizzerias, which is typical Italian, sorry for that. But in general are emission where you don't find a specific emission factor in the inventory or in the guidelines. So you need to provide local emission factor, so to have measurement on that. And for instance, in the city of Milan, this contribution is significant. So you cannot be not work on that. Then A3 and 4 focus on the comparison between CTM and PMF computation. There are, yesterday it was remembered that our projects are working on that, as Camillo and others. So again, some lesson learned. So a good agreement you see in the higher part of the graph, a good agreement between measure and CAMX in this case performed by RSC, but in a Milan station, and this is not enough because if you look at the second graph below, you see that the total organic matter is really different. So probably here you have a high underestimation of the model, and then probably you have an overestimation, so plus and minus, so two errors compensate and produce a good correlation on the total. So be careful to look at only the total of PM, but try to look at the different composition of aerosol. This make us do a focus on secondary organic aerosol formation. We are working on with a new chemical scheme in CAMX. And then, when possible, use chemical speciation, local chemical speciation. This is, of course, again, important to avoid this kind of overestimation or underestimation of the chemical part. To summarize, so we have severe underestimation of anthropogenic secondary organic aerosol in both model. In both CTM we have used in this REMY project, and mostly related to road traffic. Road dust resuspension, as I have already said, should be included in emission inventories. It's a significant part, and mainly when it has to do with urban simulation. Commercial heating burning emission estimates should be improved, and take care that temporal profile is different from residential one. So even though they are in the same macro sector, which is macro sector 2, please use a different temporal profile. Some local emission factor should be used when you, for instance, you see pizzerias in Milan or residential heating in Poland, and time profile is fundamental. In the industrial sector is very uncertainty when you look at small industries that could count a lot on the total. Finally, which is the urban contribution on bottom-up, very detailed inventory and detailed modeling. We have seen yesterday the improvement of the results in modeling, and we have found the same. So the urban modeling can improve CAMX performances and get better the peak, and you see CAMX, it's the green when you have underestimation respect to observation, which are blue, the red, which is the urban, it's better working. Final slide, it's about the last thing we are doing. It's to re-simulate base case, trying to include in the emission we are simulating the lesson learned. So we are improving the residential and commercial heating with the new emission factors. We are including particle resuspension evaluation, and we are including the new scheme, the new chemical scheme on secondary organic on CAMX, and we are using outside the local inventory the MF relocation with the use of special indicators. So we will see if this improvement in the emission used in the model will reduce or not the results in concentration. So thank you very much for your attention.